Hi, this is our calorimetry lab where we use specific heat, or we're going to use try to find the specific heat of copper and see how close we are. So hopefully you read the background information. We can see that we don't need a lot of materials. One of the big safety concerns here is because we're going to be heating things, we're going to assume that everything is hot. So one of the most important things in this lab will be putting hot materials on the wire gauze. All right, so we are going to find the initial temperature of each piece of copper by using Q of the system equals Q of the reaction. Now remembering that Q equals MC delta T. If we need to go back to our notes and know what all those things are, this would be the time. All right, so let's hit the procedure. The procedure is not very difficult. Get your safety goggles on. As you're watching this video, you don't need to do that. And obtain 3 masses of copper and record them. So you're going to record these values right there. So let's do that quickly. Here's my 3 pieces of copper. So let's put the first one on. So our first one, there's the mass. Now I'm also going to set that over here so I know that this is the first one. So again, record. And let's get the second piece. Go ahead and record the second piece. And let's get the last piece. All right, we should have the 3 values for the copper wire. Now, it says using the RTI cup. Well, that's just our fancy Yeti cup right there, but it's not a Yeti, it's the RTIC. And it says fill up with 75 milliliters of water and determine the mass of the water. Well, we could do this in a couple different ways. If you know the density of water, you could do some assumptions. But what I'm going to do is, let's do this. I'm going to put this on there, and then I'm going to zero it, because we don't want the weight of the graduated cylinder. We want the weight of just water. So I'm going to 0 it. And now, let's fill this up with 75 mils of water. Now, the exact amount doesn't have to be 75. The weight is the important thing, but 75 works pretty well. So here we go. And I'm going to stop. I'm a little bit over, but we can use that value. Maybe dump just a little bit out. There we go. We're pretty close there. So now, that number there is the mass of water. So go ahead and write that down in the mass of water for the first one. Okay, now I'm going to place that in our imitation Yeti cup. And let's see what we do next. Take the temperature of the water before you run each trial. So here is my thermometer. Let's put that in the water. Now, when we put it in the water, we might want to take just a second or even swirl the water. I'll try to do this here and see if the temperature changes just a little bit. Now, I don't see any change in there. So now, you can see, I'm going to turn this, maybe easier to see. There's our temperature in Celsius. Make sure you record that correctly, not the final temperature, the initial temperature of the water. Now, we are on step 4. Using the tongs, heat a sample of the copper over a Bunsen burner for 15 seconds. Drop the copper wire into the the water and swirl. Take the temperature when it stabilizes. So I'm going to set our camera up so we can see this in action. All right. So now let's start the Bunsen burner up. Get everything ready. We're going to put this top on because this Yeti is going to take care of not letting the heat escape. That's the whole idea. So here, turn on the gas. Adjust that flame. Now, we'll count to 15 seconds. And ready, go. 1, 2. And as you see, it's getting nice and bright red. That's a little bit over 15 seconds, but that's okay. We're just looking at the initial temperature and drop it in. You might have heard a little sizzle there. Now I'm gonna just swirl the water here, and you can see right off the bat, if I stop real quick, the temperature is raising. So I'm gonna keep swirling this. That piece of copper got the water to heat up. So, doesn't look like it's raising anymore. So now, take that temperature, well, went up just a little bit. Let's use that right there, 26.1. That should be our final temperature of the water. Now, it says repeat that steps for each thing. So in the next videos, I won't explain as much. I'll just do it, and then you'll write down and make your calculations. All right, here we go.